Okay, and so today we will use the library dplyr. So if you haven't done so already, go and do install.packages dplyr on your computer and load up library dplyr. We'll also make use of the EDAWR thing. So if you're restarting your R session, load up library EDAWR, because we'll take a look at the pollution table again. So we've got EDAWR and going back to dplyr. So load those libraries up. As far as dplyr goes, there's a few functions that we really want to learn. We've got select and filter. We have mutate. We have arrange. And then summarize and group by go together. And those are very powerful functions. And I would say dplyr, the source of dplyr's power comes in summarize and group by. Okay, we'll also be using data from this package called NYC Flights 13. These are flights from New York City in 2013. It's a pretty large table, so make sure you load that up as well. So, and if we take a look at flights, flights is a table with 336,000 rows, or over that, 19 columns, and they show up here, and I can ask structure of flights. Oops. And there we go. So it includes things like, you know, the day of the flight, date information, departure time, scheduled departure time, the delay, arrival time, scheduled arrival time, and so on and so forth. All right, so that's New York City flights. We can use dplyr to subset our things, okay? And so we have extract variables. Select is kind of like selecting columns, and filter would be selecting rows. So it is true that a lot of the functions in dplyr can be done with base stat functions already, but dplyr, in my opinion, makes this a lot easier, and so it's worth learning. So we have select for selecting columns, filter for selecting rows. Mutate will create new columns based on the currently existing columns. And summarize will change the unit of analysis, meaning that in the beginning, the unit of analysis would be one row for every flight. So each row is the unit of analysis. And we can change that to say we want to group by the carrier, or we want to group by the month. And we can summarize and say, you know, the month of January looked like this and the month of February looked like this. Or if we group by the carrier, we can say United Airlines looks like this and Southwest Airlines looks like this and American Airlines looks like this. Okay, so the way select works is you just say select, you give it the table name, and you type in comma the columns that you want to select. So if I pull up storms, it looks like this, and I can say I just want to select from storms the column storm and wind, and it will just select those two columns. We can use the minus notation to say select everything but this column. So I can say select everything other than the column storm, and it will return wind, pressure, and date. And we can say, we can also use colon notation with dplyr. So we can say select the columns wind through date. So we can use wind colon date. So that's kind of nice. If we looked at the flights thing, we can say I want to select just the columns between departure time and scheduled or arrival delay. So I can say departure time colon arrival delay. Oops. So I can say select from flights departure time colon arrival delay, and it will select just those 6 columns, departure times through arrival delay. And actually, because it's a tibble, it doesn't all fit. Here we go. I have to expand the thing, and all 6 columns will fit there. Yes, question?
Is it possible to assign something select to a variable? Or be selected, does it count as its own like, data frame? Or
Yeah, so when you run select, it creates a new data frame with just 6 columns. And so if we wanted to feed this into a thing just called like time info, I can do the assignment operator.
Okay, cool.
And now I've got time info is a data frame with 6 variables or 6 columns and 336,000 rows. Okay, I'm going to get rid of that though. All right, with select you can do some nice little things such as ends with or starts with. So with flights I can say, and we can use the pipe notation, so I can say take flights, pipe it into select, and in select I would just want those that starts with DEP for departure, okay? And it selects departure time and departure delay. Or I can say select only those that ends with time, and it will select these ones. So those are just some nice little features you can do, ends with and starts with, and then all of these other things. And again, the colon notation is nice because you can just say the actual variable name and select from this variable through this variable, rather than with subset you would have to say variable 5 through 7 or something like that. Okay. Filter is for rows. And so with rows, this is much like subsetting, except here we're using the verb filter. And so you say filter the table storms, and we will do where wind is greater than or equal to 50. Okay. If you want to have additional conditions to filter on, you just put in a comma. Okay. So filter, you can use ands or ors. If you use a comma, it's equivalent to saying and. So you can say filter where wind speeds are greater than 50, comma, meaning and, where the storm is in Alberto, Alex, or Allison. Okay? And I think this part is clear enough. So you got select and you got filter, and that's good. So we've got logical tests in R for filtering. We've learned all of these before. Group membership and equal to and all of that. Over here we have mutate. Mutate will take other variables and create a new one. So here we're going to say mutate storms. We're going to take the storms table, and over here we give it ratio. This is going to be the new column. Create a new column called this, called ratio. And the way you're going to calculate ratio is you're going to do pressure divided by wind. And so it just does its vector operations and calculates your ratio there. And that's simple enough. A nice thing about dplyr is you can add multiple columns through mutate. You can do ratio and inverse. And if you want to create additional columns, such as inverse, you can have it reference columns that you just created. So normally in R, if you said create a new column called inverse and you called it and said take ratio and raise it to the -1 power, R would get confused because it'd say, I don't know what ratio is because you just created it in the same thing. dplyr is smart enough to say, oh, you created this thing called ratio, and now we can use that thing and create inverse. So you can all do it in one line here. So dplyr is really just about making your life easier rather than saying mutate, create a new column called ratio, and C bind it on. and then take a column, take that ratio, inverse it, and then C-bind it on, right? So that's normally how we'd have to do it, right? We would say wind pressure divided by, or pressure divided by wind creates a new column, vector of values, and we would C-bind that vector of values to our data frame. Dplyr, one key. Okay, and then with mutate, you have a few what we call window functions that do things like cumulative mean, cumulative sum, and things like that. So here it takes a vector of values and it returns a vector of values. Because if you wanted to add a new column, you need a vector of values. You can't just add on one value, right? So with the ratio column, we're taking the vector of pressure, dividing it by a vector of wind, and we're getting a vector of pressure values, and that's why we can add that column on, no problem. If you wanted to do something like sum, that would not work because sum would just give you one value. So you would need cumulative sum, which gives you a vector values. And this is the running total as you're going down the column. Okay. And then our last and probably the most powerful verb or function that exists in dplyr would be summarize. This is summarize spelled with an S because Hadley Wickham is from New Zealand, so they spell it the other way. In America, we normally spell this with a Z. They might have just updated it to allow for a Z. I don't think so. I think it still uses the S. So summarize with an S here. Okay, and so if we look at the pollution table, we can summarize it and say calculate the median and the variance. And we would say we're going to take pollution, we pipe it into the function summarize, and we say median is equal to the median of the amount column, variance is equal to the variance of the amount column. This currently is no different, so if I look up pollution, this is no different than saying pollution $amount and then piping it into median, okay? Or piping that column into variance. But we can do it with the command summarize, pollution summarize. And what we say is, I want you to create a new column called median, and that's going to be the median of amount. And I want you to create a new column called variance, and that's going to be the variance of amount. Okay? And so it creates that. So it's just boiling down these 6 rows into one row. Okay? You can use other functions, mean or sum. If you want to count how many rows you have, you can do n is equal to n parentheses, okay? So we can say create a new column called n, which will tell you how many rows you have. And that one's still using median and variance, and I know this one uses mean and sum. Okay, so we're just boiling this down to one row. Yes?
So the summarize function makes its own data table?
Yeah, it creates a new data table, yes. So all of these things will return a new data frame or tibble that we can use. And we have some useful summary functions. You're, of course, familiar with mean and median and all of these things, but then you also have n, and you have first, and you have last, and all of that.
Can you explain again what it does when you call the mean and the sum function? 2 previous slides. Here, yeah, that.
So here, I didn't call mean and sum, but I can do that. I can say create a new column called mean, and what I want you to do is take the mean of the column amount. So all it's doing is it's taking pollution $amount, and then I'm just calculating the mean of these values. That's all it's doing. So we're saying pollution, feed it into summarize, create a new column, and so I can call this thing, I can call this whatever I want to call it. There's no inherent meaning. It's just saying create a new column called this, and the way you're going to calculate that is taking the mean of the amount column. So these are summary functions. summary functions are most powerful when we pair them up with the group by function. Okay, but before we get to the group by function, we're going to take a look at the arrange function, which is basically just sorting based on certain variables. So I can say arrange the table storms based on the wind column. And so we can see over here storms are arranged in alphabetical order by the name, and over here we're going to arrange them by wind. Okay. And so here we can see that it's increasing, so that 40 is at the top and 110 is at the bottom. If I want to arrange them in descending order, I would do descending wind. I would do arrange and then descending around the wind column. Okay. We might want to break ties. And so here we have two rows that have wind speed of 45. And so we might want to break that tie based on the date. And so with arrange, you would just say storms, arrange on wind, and then if there's a tie, arrange on date. And that's what this would do. So over here, it was just in the same order that it appeared in the original storms table. And if I do arrange by date, it will arrange them by date and switch those around. Okay. And again, we're familiar with the pipe operator, and so instead of doing select storms, storm, and pressure, we can just say storms, pipe it into select, where we just select storm and pressure. Or instead of saying filter storms, where wind is greater than 50, we can say storms, pipe that into filter, where wind is greater than 50. And over here, I could say pipe storms into filter, where we're getting those greater than 50, and then of those, select just the columns storm and pressure. So we can just keep piping things into each other. And so what will happen here, I'm taking storms, we're piping it into the mutate function to create something called ratio, and from there we're going to select storm and ratio. So we're going to get, what we're going to end up getting is a table with just two columns, storm and ratio. And if you want to quickly enter the pipe operator, Command-Shift-M or Control-Shift-M if you're on a PC. So you don't have to keep typing percent greater than percent. You can just Command-Shift-M and it will throw the pipe up. All right, this is the power of dplyr, in my opinion. So earlier I showed you summarize, right? We summarized this table and it boiled all 6 rows down into one row here. 42, a mean of 42, a sum of 252, and is 6. What we can do is we can group our observations by the city. Okay? And we can say, oh, you know what? Within our table we have New York, we have London, and we have Beijing, and I want to calculate the mean, the sum, and the count for each of these groups. Okay. dplyr makes this very easy. If we didn't have dplyr, we would have to do, you know, a little bit of gymnastics in that we would have to split all of our data, this table, into, you know, 3 different tables, or we would have to, you know, run a series of subsets or something. We would split this up, and then we would apply the function mean, sum, and n to figure out these summary information. And then if we want to merge these back in together, we would have to combine them. All right, and we have a few functions that kind of do stuff like this, such as tapply and sapply, but a lot of times they crash on us or don't work the way we expected. And so I think dplyr has really made this a lot easier. So all we have to do is we use group by. We tell dplyr that there are groups that exist in the table, and then we give it the summarize function, and when it runs the summarize function, it will summarize on the groups, not on the entire table. So earlier when we ran summarize, it took all 6 rows and threw it back into one. It summarized the entire table into one row for us. If we say there's 3 groups here, or there's groups based on city names, it will summarize it and give us 3 rows back in our summary table. So the first thing we would do is we would take pollution. So this is our pollution table. It looks like this. And I can pipe this into the function group by. Group by, and we're going to say group by city. And when we do that, it looks like nothing has really changed. Okay? And it's true, nothing has really changed, except now we have this thing that says groups. We've grouped by city, and there's 3 groups. Okay? So I'm going to take pollution, group by city, and then I can pipe that then into summarize. And with summarize, let's create a mean column, and this is going to be mean of amount. Okay? And indeed, it has summarized the mean column and given us 3 values. It says for New York, the mean amount of pollution is the mean of 23 and 14, and that's 18.5. For London, it's the mean of 22 and 16, and that's 19. And for Beijing, it's the mean of 121 and 56. And so it gives us 3 rows back in our summary table. Whereas before, if I didn't do the group by, my mean would just be the mean of the entire table, and I would only get 1 value. So here, because I've done group by, I'm getting 3 rows back. So group by applies kind of these invisible groups. dplyr is aware of them, and then we ask to summarize it, and it will give us back the summaries for each of those groups and stick them together into one table. Okay. And so perhaps because I just did it so quickly and easily up on the screen, you guys can't appreciate how much effort this really has saved you. So if you didn't have group by and summarize, I promise you it is a much more headache-inducing task to try to summarize information in a large table. Right now my pollution table does not have groups, but if for whatever reason I said we're store into pollution after we've applied the groups, I can do group by. Okay, so now pollution has the groups, right? So I did pollution, group by city, and we're going to store that back into pollution. So now pollution has this, and I can summarize pollution where mean is equal to mean of the amount. This is exactly what we had before. Let's say I wanted to change the groups. I can ungroup pollution. Okay, and so I would store this back into pollution. I'm going to ungroup pollution, and here I can take pollution and I'm going to group by size, and then I will summarize. How many rows will my new table have here? I will have 2 rows, right? 1 row for large and 1 row for small, because I've grouped by the size of the particle rather than the city. Okay. Over here, here's another table. This is it's got the countries Afghanistan, Brazil, and China. We have the years 99, year 2000. We also have sex, female, and male, and all of this. Here I could apply group by country and year. Okay, and so over here I would have in light, the blues would be Afghanistan, the greens would be Brazil, and the grays are China. And the light blues are Afghanistan 99, the dark blues are Afghanistan 2000. Brazil is, light green is Brazil 99, dark green is Brazil 2000, light gray is China 99, and dark gray is China 2000. So that is group by country and year. I've created 6 groups here. And so I can summarize and say how many cases, and this would be the sum of the cases column. And so here I would end up having a total of 6 rows. I would have 1 row for Afghanistan 99, 1 row for Afghanistan 2000, 1 row for Brazil 99, 1 row for Brazil 2000, so on and so forth. I can further summarize that table, and it recognizes that because we had two tiers of groupings, we grouped on country and then by year, it recognizes that it can further combine the countries. And here it will combine Afghanistan 99 and 2000 into just the Afghanistan column, or Afghanistan row here, Brazil row, and China row. Right? And so in our table here, we can apply summarize at two tiers, and it will go 1 tier at a time as far as the groupings go. So if you have multiple layers of groupings, you can summarize them and it will shrink them back at one level at a time. Yes?
Would that just be the same as grouping only by country and then running?
Yes. So if you wanted to go straight to this table, you could just do group by country and then summarize. That's true. But perhaps you also want this, and you can do group by country and year, and you would get this table after you summarize. But then if you apply summarize again, it will shrink it down here. So it'd be like, it would be as if you removed this line that says year and this line that's summarized on that. Okay. So, you know, as we continue applying summarize, you know, eventually we'll get down to just summarizing the entire table where there were just 24 cases. Okay. So let's play around with dplyr a tiny bit. Did you guys get New York City flights loaded onto your? So you'll want to do install.packages NYC flights. So I think that's on page 80. Yeah. So install.packages NYC flights 13. And load up that library, NYC flights 13. And we can start to mess around with this and try to, you know, use the power of dplyr here. Okay. So let's take a look at our flights table. Okay, and I'm going to just do structure flights to see. So let's say I posed you a question and I said, which airline had the greatest proportion of delayed flights? Okay, so you know we have 336,000 rows here, and I said, you know, which airline had the greatest proportion of delayed flights? How could we do this? Okay, well, without dplyr, what would we want to do? Okay, yeah.
Group by airline?
Yeah, okay, so we would group by airline, okay? And I think in our table, so we can do, so I'll just do flights, and I'm going to say group by, and it's called carrier. The carrier is the airline, okay? And it will say, okay, we've got 16 carriers here, okay? And I think I can run unique. Oh, shoot, stop. That's not going to work. Okay. I want to do select carrier. Let me just select the carrier, and we want to feed that into unique. Okay, so here are my 16 carriers. I think YV is Southwest, and this is United and American, and I don't know what these other ones are. Delta, MQ, US, I don't know what these things are. Whatever. Okay. Well, somewhere these are airlines here. Okay, so we have 16 of these, and so if we wanted to do these manually, I could try to find out what proportion of United airline flights are delayed, right? So I could do let's just do one of these things. So we'll do structure flights, And let's just say, okay, well, let's find out how many of United Airlines flights were delayed. So I would do flights, and I would filter where carrier is equal to UA, right? Okay, and I've got 58,665. And we have this column for departure delay. Okay, and so departure delay, we're going to just say how many of these have departure delays greater than 0, right? And that would mean it's delayed. I guess we can ask, maybe if it's 1 minute delayed, we're not annoyed. We can say if it's 10 minutes delayed, we'd be annoyed or something. I don't know. We could say, but let's just say, you know, how many flights from United have departure delays greater than 0? So I can filter this to, so we had a total of 58,665. I can further filter this to say departure delay is greater than 0. Okay, and 27,261, right? So I would do 27,261 divided by 58,665. And we would get 464, about 46% of our things had departure delays greater than 0. Is that okay? All right, and then we can do that for United Airlines. We can do that for every single carrier and try to figure out which airline or which carrier had the greatest proportion of flights where it had a greater than 0 departure delay. With dplyr, we can make our lives a little bit easier here. We can do flights, and we're going to group by carrier. Okay. And what I want to do is I'm going to I want to summarize this. And, you know, I'm trying to think how I can do this. I'm going to do summarize. What we want is okay, actually, what I'm going to do, and I hope this works, I'm going to create a column called delayed. We're going to create a column, I'm going to use mutate to create a column called delayed. And delayed will be departure delay greater than 0. Okay, and so this just creates a logical vector for delayed being greater than 0. And we're going to feed that into group by. We're going to group by carrier. I hope this works. I'm doing this on the fly, so there's always a little bit of risk here. We're going to group by carrier, and then in our summarize, we're going to take the mean of our delayed column. I got a bunch of NAs. Let me do na.rm equals true. So my number's a little bit off here. But here it has calculated. So for whatever reason, I'm getting some NA values. But it has calculated, you know, what proportion of these are true as far as the delayed column goes. And it says, you know, about 47% of United Airlines flights are delayed. I wonder, Let me just do proportion. It's going to be departure. Okay, well, I would say that's still, and so it's calculated the the proportion of flights that are delayed for each of the carriers, and it did it very easily for us. I'm not entirely sure why I'm getting so many NAs. Yes, question?
Can you count the number of true and then divide it by the sum of each carrier?
Yeah, let's see. Okay, so mutate, departure delay. Okay, so we'll do summarize, and we want the number of trues divided by the number of in the thing. So I've got n equal to n. So this will be how many flights each carrier had. And then we would say delayed will be, let me flip back here, and we'll count how many, oops. Can I sum up the delayed column? Will be sum delayed, and I'll do na.rm equals true. Okay, so this is what I have. 27,261. Does this match what I had earlier for? Yeah, 27,261, 58,665. Okay, so I've got the total number of flights, the total number of delayed, and then I would create a new column, mutate proportion, which will be delay divided by n. Okay, and this lines up. So I think somewhere, so probably in our flights thing, we have a few NA values as far as the departure delay column goes. So this will also do it. So we've counted the total number of flights for each carrier, the total number of flights that were delayed, and then just by doing one divided by the other, we've calculated a proportion of flights that were delayed. And so if I wanted to arrange these by proportion, descending, we see that WN, whichever carrier that one was, has over half of their flights have a non-zero delay, and United Airlines ranks 4th as far as number of delayed flights, and US Airways, I'm guessing, has the fewest number of delayed flights, or fewest proportion of delayed flights. Okay, and so I don't know if you guys can follow this, but we started off by doing flights. We've piped it into mutate to create a logical vector of whether it was delayed or not. We grouped it by carrier, and then we used the summarize function to summarize how many flights total there were, how many were delayed, and we had to remove the missing ones because I think there were some missing values in the departure delay column. So we removed those, and then using mutate, we've created a new column called proportion, which just divides one over the other, and then we've arranged it in descending order by proportion. Do we all follow that? Okay, and so, yes, question?
For the n equals n open parentheses,
yes.
What exactly is being put into the n?
So the n open parentheses just means how many things are in the table. Okay, so when we grouped by carrier, it's going to just say how many rows is it summarizing here. Okay, so because basically when you do summarize, it's taking a bunch of things and it's collapsing it into one row. And so what n does is it's saying I'm taking all the rows in the original table that had United Airlines as the carrier, and I'm collapsing it into one row. How many rows did I collapse into one row? 58,665. Okay, and over here, because I'm summing a logical vector, that's going to just turn out to be how many fit this criteria. Okay, I can just modify this and just say, okay, what proportion of flights are delayed over 10 minutes? Okay, and we can see if this changes things. Okay, and so now WN, whichever carrier that one is, no longer the worst. United Airlines is now only in 8th place with only a 25% of their flights delayed over 10 minutes. US Airlines still in the lead with only 14%. And I don't know what HA is. Hawaiian Airlines? I have no idea. Okay. They don't do very much flying. And of theirs, only 8% were delayed over 10 minutes, okay? So, or we can just change this and say how many were delayed over 60 minutes. So, I don't know, YV or EV, whoever they are. About 13% of their flights delayed over an hour, which feels like a lot to me. But I don't know any, I don't fly that often, so maybe in a 1 hour departure is not that big of a deal. But we have this, okay? So we can see which months have the greatest number of delays, right? So I can do group by month. Okay, and so these are, I've grouped by the month. Flights mutate. We're still doing how many delays are over 60 minutes. And as far as the month goes, it's grouped them together. And apparently July and June have the greatest number of delays, followed by December. I guess these are the heaviest travel months. No, they all have about 28,000 flights. So I was expecting something like February to have a bunch of delays because of the storms, but it's not so bad. At least for departure delays over 60 minutes. We can try 20 minutes and see if that changes things. No, it's about the same. Approximately the same ordering as far as things go. So, it's very easy to just change kind of the command. You just press up and then you just say, oh, I want to change my delay amount to this quantity. We're creating a new logical vector here, and over here we're just grouping by different things. Is there a particular day of the month that, day, month, year, where things change? I don't know. Who knows? This is interesting. The 22nd of the month, I don't know if that's any worse than any other day of the month, but we have something like that, okay? So dplyr, really, really powerful in that you can just apply a bunch of summary things based on pretty much any grouping variable that you want to think of, and it will do stuff like this, okay? Any questions on all of this? Okay, I'm skipping over some of this stuff over here with, where did it all go? Joining data. Okay, so are you guys familiar with left joins, right joins, and inner joins? No? Okay. So if you learn SQL, there's this stuff called left join, right join, and inner join. And I don't know if it's worth covering. If you got like two tables and you want to like merge them together, okay? Left join will take all the rows in your left table and will just find the matching ones in the right table. And if it doesn't find a matching one in the right table, it will give you an NA, okay? The inner join will take all the values in the left table and only return the ones in the left table that also have a match in the right table. Okay, so over here we have Peggy Sue is in the left table and there's nothing that matches in the right table, so Peggy Sue shows up over here with an NA. With the inner join, Peggy Sue's in the left table, there's no match in the right table, so you get that row gets omitted with a left join versus an inner join. The semi-join will only do the column in the, it's like an inner join, but you have to specify the thing that it's matching. So this is kind of like, did you find matches in this thing? The anti-join is like the difference, which one is in the left table that's not in the right table. If you ever have to work with databases in SQL, just do a quick Google search on left join versus inner join versus right join. There's tons of resources, tons of little diagrams that try to show you how all of this stuff works. And so it's not too bad. Okay, we'll end here. I'll stick around for a little bit if you've got questions regarding your tic-tac-toe, and then if not, we'll see you guys. Have a good weekend. We'll see you guys on Monday.